With everything that's going on in the world today, it's a pretty smart bet to have some gold and silver around. And for all of you stackers out there, once you learn to refine gold and silver yourself, your days of paying a penny over spot are over. No more paying dealer premiums ever. You can buy scrap jewelry for less than spot many of the times, and even begin making a profit. So in this video, I'll show you one method I use for refining 2 ounces of gold and 3 ounces of silver at the same time. Thanks for watching, and let's get started. So once I've cleaned all the gold well, I go through everything and cut off the clasps that have steel springs in them. The metal springs in the clasps need to be removed, but these ones are going in with the other gold I'm saving for the apocalypse. A sheet of paper works well to pick up all those little pieces that want to roll onto the floor. Once I get all of the gold that I want to refine into a container, I'm going to switch gears to clean up some sterling scrap pieces that I want to alloy with the gold to bring the gold concentration below 6 carats, or 25%. The process of inquartation allows you to refine some silver along the way, but you could use pure silver as well. So next we'll want to get a weight on our 14 karat gold. So I've tared out a little plastic bag here, and we'll just fill that up with the gold and then get a weight. Looks like 104.9, we'll just say 105. And we know our multiplier for 14 karat gold is 1.265, so 105 grams times 1.265 is 132.8. So 133 grams or a little over of silver is what we'll need to inquart into our gold to get the carat weight down to 6 carats, 25% gold and 75% other metals, mostly silver. I'll work on getting the rest of this into the crucible, and then let's bring it over to the furnace. So our gold and silver's been in the furnace for about 15 minutes. I'm going to take it out and give it a good stir. I just use a graphite rod to give it a good stir, make sure it's mixed thoroughly. We'll put it back in the furnace for just a few more minutes, and then we'll get ready to pour. So I plan on further refining the silver and gold alloy, and you want as much surface area as possible when you make this pour. So I'm just going to pour it into a bucket of, I got a 2-gallon bucket full of chilled water, and pouring shot, you get plenty of surface area. The acid will react quickly, fairly quickly with it. What also works well, you could pour a bar and roll it out, and get a real thin piece of alloy, which also works really well. To get started, I'm going to pour in 500 milliliters of distilled water, and I'll titrate in 67% nitric acid I'll start here with about 10 milliliters and work my way up. So the nitric acid will dissolve away the silver, but it won't do anything to the gold. So what we'll be left with is the silver, the copper, other base metals will go into the solution of nitric acid and distilled water, and the gold will be left behind as a solid in the beaker. So I have about 80 ml nitric acid in solution right now, and the color's getting pretty dark, so it's fairly saturated solution. So I'm going to go ahead and pour this off and get some fresh acid on here. So one thing to keep in mind, this type of refining when you're dissolving gold and silver in nitric acid can take hours upon hours, usually 2-3, for the amount of gold that we have here. But if you plan on walking away, it's smart to add a little bit of extra water, or at least check the amount of water that you have, because it is boiling off, so the amount of water is being reduced, and that's increasing the concentration of metal in solution. Now you can concentrate quite a bit of metal in 100 milliliters of water, so it's nothing to be overly concerned about. But if I know I'm going to be walking away for a little bit, I'm going to make sure I add just a hair of extra water so that I don't boil it all off. Add a little more nitric acid. And just as an experiment, I had a gold button that I had refined quite a while ago, and it wasn't very pure, so I'm going to just throw it in this batch, and I kind of just want to pay attention to what might happen to it. So by the looks of this boil here, it looks like we've got most of the silver and copper has gone into solution, and we'll continue to boil until we don't have any color left, or very minimal color left boiling off, and then we'll be down to pretty much pure gold. Here in the flask on the left is all of our silver nitrate, and by the color, that dark blue color, you can tell there's quite a bit of copper in that solution as well. So we'll obviously save that for later, and we'll refine the silver out of that. Here now I want to pour off this liquid in here, because there's a lot of active nitric acid in this last boil, and so we'll pour it onto some other sterling pieces and kill off the rest of that nitric acid. I'm going to give it a couple of rinses here, and that solution's actually looking pretty blue, so we're going to get this back on, and we'll add some more water and a little more nitric acid, and we'll continue to boil it. So up to this point, using nitric acid, you'll remove 99+% of all the copper and silver and other base metals. Of course, to make sure that our gold is as pure as it can be, we are going to dissolve this next in aqua regia. So after that final boil, our nitric acid and water is almost totally clear. So that should mean that here we have almost perfectly pure gold. But to make sure we can get the highest purity gold, we're going to want to now dissolve this in aqua regia. So aqua regia is 3 parts hydrochloric acid and 1 part nitric acid. Typically, I'll just put the hydrochloric acid on the gold first, and then titrate in the nitric acid as needed, 3 to 5 ml at a time, depending on the amount of gold. In most cases with cold hydrochloric acid and cold metal, you can start off with a little bit more nitric acid, say 10-15 ml, maybe as much as 20 depending on how much gold that you're starting with. And as the fumes die down, obviously titrate in nitric acid as needed, being very careful not to add too much nitric acid. And I'll explain why later. Here's a good example of what happens when you add too much nitric acid too fast to hot metal in acid. So now that we're down to just a few grains of gold left at the bottom, we're going to want to add our nitric acid, 1 milliliter at a time, very carefully, not to put in too much nitric acid. The reason for not wanting to add too much nitric acid at this point is it's going to need to be neutralized before you can go on to the next step. So I'm just going to wet out my filter paper, and I'm using a number 2 Wattman filter paper, and then we'll run our gold through the filter and rinsed out of the beaker here, and get ready to precipitate out all of our pure gold. I'm going to pull my little gold button out here, and I can see that basically nothing happened to it. So here we had a little bit of dirt and filter, so I went ahead and filtered this twice to make sure it was absolutely clean. So I'm adding ice to the beaker here to cool down the aqua regia. We're going to add sodium metabisulfite to precipitate out the gold, and having some ice or an ice bath just to help keep everything cool will help from anything spilling over. So we'll just let the gold settle to the bottom of the beaker, and when it does, we'll pour off the solution on top. As part of kind of cleaning up, is I'll just take my leftover solution and I'll pour it right back through my Buckner funnel, and it just uses it to kind of clean it out. If there's any gold left in there, that solution will actually precipitate it out, and then it can be flushed out and rinsed to the bottom. I'll do the same thing with, I had a little bit of leftover aqua regia that dripped out of the funnel, and I'm just going to show you here, when I pour this solution right into aqua regia, you'll see then it works the same way, and the gold falls out of solution. So now we'll get these 3 beakers of gold all collected together into one beaker. So here we're just going to take some hydrochloric acid, and we're going to pour it on top of our clean gold here, and if there is any base metals left, we'll notice in this step there'll be some fuming, and you'll also see discoloration of your hydrochloric acid. So we'll get this turned up, and we'll let this cook for maybe 10 to 15 minutes. So here I noticed there was a little bit of color in that hydrochloric acid, so I went ahead and we boiled it one more time, and now you can see that we've got crystal clear, and boy, that looks nice. So now we'll get this transferred over here into a crucible before we fire it in the furnace. I'm just going to pour it right in, and then I'm going to siphon off the remaining water. And then what I'll do is just put some real low heat on it. I think I just set it right on my hot pad. and evaporate off all of the water. Now just check it with the spatula, make sure it's totally dry. If nothing sticks to your spatula, then it's completely dry. You don't want to put wet gold into the furnace, you're going to have it spatter. So now we'll take this over to the furnace, let's get this fired up. So now here I just want to get a halfway decent pour on this. We are going to be cutting this into smaller pieces, so I do just want to pour out a longer bar. But it is definitely smart to level what you're pouring into so you get a nice even pour. Slow and easy does it. Oh, it hurts me every time I watch that. But now all we need to do is we could roll this out, but we're just going to cut this into, well, we want to get a weight on it first, but then we're going to cut it into the size pieces we need to remelt this. Okay, so here is our bar of gold that we've poured out, and the total weight on this bar, 57.69, so just under 2 ounces. So we'll melt up 1 ounce right now, and then I'll save the rest for another project I have later. But we're going to melt up a 1 ounce round, so we want to cut off and weigh up 31.104. So let's just guess about halfway right here.